Hello, so I'm planning to show you how I go about designing the layout of a PCB. So I'll have you follow along on installing the BSP or designing the BSP main. So um, this has been done by Filippo and Jordi, and well, the schematic is complete, at least enough to be happy with starting the layout. And so all footprints has been assigned, as you can see. And well, we have also looked in the CAD, which is a very important step. You have to see what kind of size you're working for. And you have to have an idea of what shape and stuff the board should be. So for the BSPD, it's just I've talked to Tora because it's going to be in the front department with the pedal box. And we basically want it to be as small as possible and be in its own box, which makes it a lot easier for us because we don't have to try to fit it around other systems. And the reason for this is that the BSPD is a scrutinized system and it gets its own sticker and it's locked. So if we would put it together with the other stuff in the front, like the DCU, those would not be possible to change or debug or fix during competition. So after you have run the footprint assignment tool, I have actually not done this. Let's see, you have to run the ERC check. Let's see what kind of errors. Okay, it's the errors we get are error reading simulation module. This doesn't matter. Like this is if you're gonna do some simulation in like LT-SPICE. We're not gonna do that, so we don't care about this. So these errors are okay, and the warnings, same net, that's okay. It's kind of like I think here this is saying that LEM supply is 5 volts, so it will not use the LEM supply tag or label here. But this is more for making it clear. This looks a bit shit, but yeah, it's more to make it clear. Here it was the isolation thing. Here it's gonna say ground will be used. Yeah. What else did we have? Oh, the same thing. We have here it says that it doesn't find this connector. I think it's okay. Some items. These have been modified. Yeah. This is a bit of an old schematic that has been converted. So, yeah. Same here. I mean, it's just a diode, so I don't see what the symbol being modified matters. I think it's maybe that new KiCad 7. This was probably made in KiCad 6, or it was made in KiCad 6. So probably they updated how this looks a little bit, and then in the beginning we press rescue symbols, and it's kind of saying, yeah, we updated it. Yeah, but this is probably okay. I mean, the important thing here, so we have, it says ferrite bead. It has a footprint as an 0805 piece. That's okay. Here as well, 0805, it's okay. Yeah, so 323. So this, the footprint looks okay. I think it's, yeah, as we said, new symbols in the new KiCad. So I'm gonna ignore this for now. So you press the screen button when you're ready to start the layout. So you go into here. This little thing I couldn't delete. I don't. Yeah, I have no clue how to how to access it. I mean, I can't clear it. So we'll just deal with it. So how I like to go about, if you have a very set shape which you have to adhere to, I would start with making that shape. So then you would go into. Yeah, I should probably show you around here a bit first. So let's start on this side. Here, or you know what, let's start here. So when you get in, you have to decide if you want to use certain amount of layers on your PCB. So PCB is copper layers with an isolating FR4 sheet in between. And you can choose how many copper layers you want, basically. But usually we have 2 copper layers. If you use 2 copper layers, you this will probably be on a bit of a PCB where you don't have that many cables or routings going everywhere, and it's not as tight. If you want to go to, yeah, so you will have like the front copper layer where you place all the components, and then you might do some small routing on the backside, but you basically always want a full layer that is ground. Sorry, I have to, yeah, recording, perfect. Yes, you always want one layer, which is just a copper layer, which is ground. This is for signal integrity and EMI purposes. So you want all your return currents to not form any kind of current loops, have to go around components, traces, things like that. And why is that? Well, you can think of it a bit like this. Say we have, oh my god, a Zoom window, sorry. Say we have our PCB here, and we have our power supply here, plus and minus, they come in here. And then we place some sensitive component here. When I say sensitive, I mean that it's measuring something. So it can be that it's measuring a thermistor or whatever, maybe even something more sensitive. So it can be like, yeah, I will just write sensor. Now this sensor is maybe a standard current division sensor. So we have some supply line here. We have, let's see how we would do it. We do it like this. So we have some resistor here, and then we have the sensor here. So I'll write it R sensor. So this is a simple current division. As the sensor resistance goes up, the voltage on this sense line, this is kind of how you can measure some kind of sensor. The sense line voltage here goes up, and as the resistance of the sensor goes down, the sense voltage goes down. And you have some supply here, like 3.3 volts. And this is ground, of course, so we're clear. And then we place another component here. Here we place something that consumes a lot of power, maybe the backlight screen. That would consume quite a lot of power. We place it here. Now, imagine you manually route this. So you route, we'll do it in the red. We route power here, route power here. Then we make a ground line. So we route ground here because the sensor needs it here, right? And we route ground to the minus here. I will do it in blue so we are clear. What will happen now? Well, all the current going from the backlight here will go through the same path as the sensor here. And every line here has a resistance. So you can actually, instead of doing this, you can model it as there's resistance to ground. There's more nuances to this, but just simply this is what you can do. And we know that the current coming in here, so I1 and I2, the current going through here has to be I1 plus I2, right? So these two currents, okay, not in this spot, sorry. Here, let's see. This is I1 plus I2. That's the current going back, right? Simple Kirchhoff's law. So what will happen? Well, this sensor, okay, so if we have this current, what would that mean? Well, you can't physically have a current if you don't have a voltage difference. So think about that. Yeah, we know this. U is equal to Ri, but it applies everywhere. And usually what you do is you consider ground as 0 volts, right? But if it's 0 volts here, it's 0 volts here, 0 volts here, 0 volts here. This doesn't apply. You can't have a current. The current would have to be 0. So that means there's going to be a voltage drop over this resistor, and there's going to be a voltage drop over this resistor as well. It's going to be probably very tiny, depending on how large or small these traces are and how much current is going through them, but generally pretty tiny. But still, what does that mean? Well, it could, for example, mean that the ground point here, if you have quite a large current going from the backlight screen and you have a kind of small trace, which is pretty normal on a PCB, well, this ground point, it may no longer be ground, it may be is ground plus 0.1 volts. It's quite a lot, but still, it's not impossible. Okay, what happens to my sense measurement? Well, this sense will also be affected by this. So depending on how much current we are like using from the backlight screen, the sensor will seem to shift. So maybe it looks like suddenly your temperature in your PCB rises, or it can have quite large effects on this sense line. You can get errors, and you will have a lot of noise on your measurements. It will kind of look like this, your measurements, depending on, for example, the loads in the PCB, because then you have some the MCU here or whatever, and it is connected like so. Okay, so it has its own supply, so it's referencing this point, which is pretty much perfect ground for it. So the voltage over here is adjusting the sense line. I hope that was okay to understand. So what can we do to fix this? Well, instead of having this, I will remove a lot here. Instead of having this return paths here, that we supply like this, we make this whole plane here ground. Now the current will spread out through the whole plane here, making it as low impedance as possible. And yes, you should still think about this if you have a very high consumption component and a sensor, try to not place it in the return path here. For us, we haven't really gone into this in the PCB as far as I know of. We have no sensors where we are this concerned at the moment, but keep this in mind. Don't place it in the direct path. Here, it's a lot better than having if you manually wire like this, because yeah, the current will spread out through the entire plane. And if you have a lot of routing, we'll keep the plane actually. What you can do is, well, we add a power plane as well. Boom. So now we have 2 planes. So usually what you do if you have a PCB, you have 2 ground planes, so both the front and the back copper is ground. But the front one is more for making it easy to route. It's not going to be a lot of current going through it. The current is going to go through this top layer, and then you will have what's called a via, which is a hole going through the layer. So if you look from the side of a PCB, you have, let's make the copper, this is a copper layer, this is, and so you have the copper layer like this, you have some isolating material in the middle, so current can't go through them, and then what you do is you create a via. A via is just a connection between the layers like this. So you drill through, you fill it with copper. Now the current can go like this, And usually this is what a PCB that we make look like. You have two layers, you have both of them being ground. What you can do is that you have one ground layer, you add one power layer, and these are the two middle layers of your PCB. So if I start building it up, we have the red layer here, we have blue layer here, and yeah, of course, the for in between. And then we have two signal layers. So this is the front copper. This is the front copper. And then you have a rear copper as well. So another layer. And what you can do then is that you can place components on both back and front, and you can route, you would call these two signal layers. So you can route traces here and here. And then you will use this power plane and this ground plane. And you will just, if you're running a component, this line becomes completely useless. So you would remove them. And instead what you do is you just place a via. You route out the small trace and you place a via here. And now that via is just connected to this red layer because you specify that with a via. So then you get connected to 3.3 volt, which is this entire plane. It'll make sense pretty soon. Okay, I will stop here and continue in the next video if I figure out how to do it.